Hi, and welcome to another episode of Cancer Answers. I'm your host, Heather Riffet, and joining me today is Dr. Michele Carbone, who is the Director of Thoracic Oncology and a full member in the Cancer Biology program at the University of Hawaii Cancer Center. Dr. Carbone has been at the forefront of genetics research. The focus of today's discussion is the role of genes in cancer. Thank you, Dr. Carbone, for being here. Can you please talk more about your area of research here at the UH Cancer Center?
I study how genetics influence our risk of developing cancer. How is that our genes modulate this risk?
And how do our genes actually influence the risk of us developing cancer? Because you focus on this particular area of research. So, how does that work?
Well, cancer is a genetic disease. So the reason that we get cancer is because some of our genes become, as we say, mutated, which means they don't function anymore the way that they are supposed to work. Now that happens because we age. And the only way to prevent it would be not to age, which is not an option that anyone would choose. So what happens is that every time that the cell divides, you accumulate a couple of mutations. So by the time you are 50-year-old, you have about 50,000 mutations per cell. So if some of those mutations occur in the wrong place, then the cell can become malignant. That's one reason. Another possibility is that some people are born with a mutation into their cell, with a mutation of a particular gene that we call tumor suppressor genes, which means are those genes that if they don't function, then you can get cancer. So if you are born with a mutation in those genes, then the chance that you develop cancer is much higher or can be 100% depending on what gene you have. And then you have to consider the interaction between the genes and the environment.
Yeah.
Because that interaction modulates the amount of genetic damage that you accumulate during life. And so that's how cancer develops, but then by your genetics and by what the environment is doing to your genes or together with your genes.
Right, right. And the environment also influences whether you will get cancer because of that interaction with the genes that it has. So, what can we do, individuals do, to reduce the risk of developing cancer because of our mutated genes?
Well, we cannot do anything to prevent the genes accumulate mutations because they will. But we can slow it down or decrease this risk by limiting exposure to those environmental carcinogens that can cause cancer or protecting yourself against that. Limiting means you don't smoke and you don't stay close to people who smoke. That we can all do. The sunlight is the most known and most potent carcinogen that there is. You can't avoid to be exposed to sunlight. We live in Hawaii, it's a beautiful place, but it's a good idea to put sunscreen and protect yourself because otherwise you're going to get cancer for sure.
Yes. Okay. And what new discoveries have you been able to make about genetics in cancer here at the Cancer Center, working here in Hawaii?
Here we discovered a new disease. This disease that we discovered here in Hawaii is called the BAP1 cancer syndrome. And this is caused by an inherited mutation. Inherited means that those affected by this mutation are born with a mutation of this gene that is called BAP1. We discovered that because we were studying an epidemic of cancer in some families, and they had a very high incidence of cancer, and the question was why they get cancer and why they get these particular cancers. They were mesothelioma, that is the cancer that is of the membrane that surrounds the lung, melanoma, and renal cell carcinoma. Why so many people in this family are getting this cancer? And we discovered that all the people who develop cancer were born with a mutation of this gene that is called BAP1. That was in 2011, and now there are hundreds of families, or thousands of families that we have in contact around the world who has this condition.
So the BAP1 gene it's found predominantly in a particular sex, for example, a male or female, or is it more found in in males or females? I mean,
There
what's
is a
your...
slight prevalence in women compared to men, but is not a huge difference. Either one can be a carrier of the mutation. Once you have this mutation, the chance that your kids inherit the mutation is 50-50. So that doesn't mean that in a family of 10, 5 will have or 5 will not, because if you throw a coin up, it's not that every time you get 50-50, but that's more or less the chance, 50-50.
But why is it more prevalent in females compared to males?
I don't know that, but my hypothesis is that it may be little in utero in males and not in females, and that's why we have more females than males.
Okay. And you were also, I would like to refer this back to the article that you were featured in. You were called a gene hunter of Hawaii by the American Association for Cancer Research. The article detailed your experience in Cappadocia, Turkey, where mesothelioma caused up to half the deaths in some of the villages. So can you talk more about your field experience there, what you learned, what you were able to do?
Yes, I started my investigation into it because I was studying this cancer that is called mesothelioma, that is usually caused by exposure to asbestos or to other mineral fibers. And I knew that there were these 3 villages in the middle of nowhere in Turkey, in a region close to Syria called Cappadocia, where 50% of all the people who live in the village die of this cancer, which is the most devastating cancer epidemic that has ever been discussed.
What year was this?
We are talking about 1997. And I was a young assistant professor at the time. I went there. I thought it was a touristic visit to the villages. And then when I was there, I saw the disaster that was happening there. People were asking me, I was supposedly the American expert, why they're getting cancer. I had no idea. I realized that all I had studied in school was useless because I had no idea. And I felt really bad that I couldn't do a thing about it. So when I came back, I told my chairman, Ken McClatchy, Ken, this is what I'm going to do now. I'm going to find out why these people get cancer. I'm going to help them out. Initially, they thought that was a crazy idea, and Ken tried to discourage me, telling me I would have died of the disease there, but he meant well, not bad. Anyway, I went there and I studied this disease initially on my free time, because that was not part of my job, so I spent my vacations there. And then I started getting grants, and we demonstrated that the disease was transmitted in families, and so that was a genetic disease. That was the first discovery that mesothelioma could have a genetic cause. Then many American families start to call me and say, you are going all the way to Turkey, but in our family we have the same problem. So I started studying them, and I started flying to all the surgery rooms when they had surgery. I'm a pathologist, so I would do the diagnosis and collect the specimens and then take the specimens here in Hawaii and study them. And so doing that, going around surgery rooms all over the United States, bringing the specimen here and studying it, we discovered these genes that is called BAP1 that was the cause of mesothelioma in all these families.
Right. And very lastly, is it difficult to conduct this kind of research in Hawaii, considering that the state is very geographically isolated?
Well, of course, that creates a problem, but then you need to use the problem to your advantage. So we are isolated, but it's a beautiful place. So people like to come here. I am the top expert of this disease because I discovered it. I created a very large international team that works with me, and I direct the team. And the families, we have many families who come from all over the world here to see us, to donate their specimen to us for our studies. Then we established a collaboration with the National Cancer Institute in Bethesda, where they've opened 2 clinical trials for these patients, where I can enroll all these patients and they are treated for free at the NCI. So I'm taking advantage of the technology of these times that allows you to overcome what would have been an impossible situation some 50 years ago. Today, between Federal Express, airplanes, and email, Zoom is possible to be at the forefront of cancer research for Hawaii, and this is very good also for the local kids, the students, the UH students who rotate to my lab to see that we have a team that is at the forefront of cancer research, that people from all over the world come to work with us, Nobel Prizes, top surgeons, everybody's coming here to work with us. So it creates a very exciting atmosphere here at the Cancer Center of Hawaii, which is leading from Hawaii, which is the reason that we built this cancer center.
And it's great to see how Hawaii has become this hub for generating research, cancer research for the local community, but also for those people who are coming from the outside seeking treatment in Hawaii. Thank you, Dr. Carbone. This was a very insightful conversation. Hopefully, the listeners got to learn a thing or two about genetics and mesothelioma. That is all for now. I'll be meeting you guys next week with a new guest and a new topic. I would love to know how you are liking Cancer Answers. So you can visit our social media pages at UH Cancer Center on Instagram, Facebook, and Twitter. And you can also visit our website, uhcancercenter.org. I'll see you next week. Take care. Bye-bye.